Girard Desargues was a much-respected member of Mersenne mathematical group, an engineer who later became an architect. He was an expert in classical geometry with a particular interest in perspective drawing. His earliest surviving publication is a pamphlet on perspective published in 1636. It is for the most part devoted to construction that an artist could use to create a picture in correct perspective. But Desargues was to follow this work with a book on conics. When Descartes heard that Desargues was at work on such a book, he was astonished.
I can hardly imagine what he can have written concerning conics which can be good. It is easy to explain them more clearly than Apollonius or any other, but it seems to me very difficult to say anything about them without algebra, which could not be done much more easily with algebra, as I myself have pioneered.
But Desargues had indeed done something quite revolutionary. What he did was to look for properties that were common to all the conic sections. He considered the ellipse, the parabola, and the hyperbola. With a change of viewpoint, he observed that all these conic sections could be made to line up behind each other. And from here, they all look like sections of a circle. Now, what Desargues wanted to know was, were there any properties of conic sections in general that remain unaltered by this change of perspective? The apparent length of a line obviously changed when the viewpoint changed. So too did angles between lines, but at least straight lines remained straight lines. And Desargues did indeed find several extremely important properties that remained invariant by a change of perspective. A simple one that we can derive from Desargues' work is this. Given a line xy, we say that the points A and B divide the line internally and externally in the same ratio if the length xa divided by the length ay is equal to the length xb divided by the length by. To Desargues, there are 4 points in involution, and his methods show that they survive changes of perspective. Apollonius had called it a harmonic ratio, and it crops up all over the place in geometry. For example, consider an ellipse and a point B. From B, we can draw 2 tangents to the ellipse. Label the points where the tangents touch the ellipse, P and Q. Now draw a line through PQ. 4 points in involution occur if we draw any line through B cutting the ellipse. The 4 points B, X, A, Y are 4 points in involution. And this is a construction that survives a change of perspective. However we look at the diagram, as a circle or as an ellipse, the points B, X, A, Y remain 4 points in involution. What Desargues did then was to take those theorems of Apollonius that had been treated separately for circles, ellipses, parabolas and hyperbolas, and show, using his invariance of points in involution, that there were in fact completely general theorems on conics, of which the theorems of Apollonius were special cases, as Desargues noted at the end of his paper.
Some of my theorems and their consequences contain several of the conic propositions of Apollonius, and leaving aside the lemmas, 4 of my theorems contain the entire dissection of the cone by the plane.
Boastful? Maybe, but there was a great deal of truth in it. Mersenne and Descartes both appreciated the genius of Desargues, but few followed up his line of thought at the time.